In this video, we are looking at section 10-2 in the book, Solving Systems of Linear Equations and Inequalities Using the Addition Method. The addition method with opposite variable terms. The addition or elimination method for solving systems of equations incorporates the concept that equals added to equals gives equals. When we add two equations, the result is still an equation. However, the addition method is effective only if one variable is eliminated in the addition process. To solve a system of linear equations that contains opposite variable terms by the addition method, we will write each equation in standard form, ax plus by equals c. We'll add two equations, then solve the equation from step 2. The result is one part of the ordered pair solution. Then we substitute the solution from step 3 in either equation and solve for the remaining variable. This completes the solution ordered pair, and we check the solution in both original equations. So for example, suppose we want to solve the system of equations x plus y equals 7, x minus y equals 5. Well, we'll start by just adding those equations together. X plus y equals 7, and then x minus y equals 5. Well, we add the two x's together and get 2x. We add positive y to negative y and get 0, and we add 7 and 5 to get 12. So we have 2x equals 12, and we can divide both sides by 2 and get x equals 6. So now we take that 6 and we substitute it into either of our two equations. I chose the first one. So I have 6 plus y equals 7. I subtract 6 from both sides of the equation to get y equals 7 minus 6, which is 1. So y equals 1. And the solution is 6, 1. And we check to make sure that this works in the context of the second equation. 6 minus 1 equals 5. That's true. So the solution is correct. Now, if we don't have opposite variable terms, one unknown must be eliminated. The terms must add to 0, and if neither pair of equations in a system of equations is opposite terms that will add to 0, we multiply one or both of the equations by numbers that will cause the terms of one variable to add to 0. So to solve a system of linear equations that does not contain opposite variable terms using the addition method, first, we write each equation in that standard form again, ax plus by equals c. Second, if necessary, we multiply one or both equations by numbers that cause the terms of one variable to add to 0. Third, we add the two equations to eliminate a variable, and then solve the equation that we get from step 3 for the remaining variable. Then we substitute the solution from step 4 in either equation and solve the remaining variable, and we check the solution in both original equations. So for example, we can solve the system of equations 2x plus y equals 7 and x plus y equals 3. There are several possibilities for eliminating one variable. We could multiply the second equation by -2 and eliminate the x's. We could multiply the first equation by -1 and eliminate the y's. We could multiply the second equation by -1 and eliminate the y's. I'm going to do that. I'm going to multiply the second equation by -1. So if we have 2x plus y equals 7 and -x minus y equals -3, we add those things together. 2x minus x is x, y minus y is 0, 7 minus 3 equals 4, so x equals 4. Then we have 4 plus y equals 3, which means y equals 3 minus 4. We've just subtracted 4 from both sides of the equation, which gives us y equals -1. So our solution is 4, -1, and we check to make sure this works in the context of the other equation. 2 times 4 plus -1 is 8 minus 1, which is 7, which is what we're looking for, so the solution is correct. When an original equation is altered, it's important to check your solution in both original equations. This enables you to identify mistakes, such as forgetting to multiply each term in the equation by a number. So for example, we'll solve the equation of the system of equations 2x plus 3y equals 1 and 3x plus 4y equals 2. In this system, no integer can be multiplied in just one equation to eliminate a variable. So we need to multiply each equation by some number, and we're going to multiply the first equation by 3, which will give us a positive 6x, and the second equation by -2, which will give us a negative 6x, so we can eliminate our x's and figure out what we get from the y's. So that gives us the equations negative 6x plus 9y equals 3, 6x plus 9y equals 3, and negative 6x minus 8y equals -4, which leaves us with y equals -1. We plug that back into one of the original equations. I'll use the 2x plus 3y equals 1. 2x plus 3 times -1 is 1. So that means that 2x minus 3 equals 1. 2x equals 1 plus 3, which is 4. So 2x equals 4, which means x equals 2. So we've got the solution to -1 now. We check this in both equations to make sure it works. 2 times 2 plus 3 times -1 is 4 minus 3, which is 1. 3 times 2 plus 4 minus 1, 4 times -1 is 6 minus 4, which is 2. The solution works in both equations, so it's the correct solution. As noted previously, some systems of equations have no solution. When we try to solve the system of equations x plus y equals 7 and x plus y equals 5, we must first multiply either equation by -1, and I'll use the second equation for that. That gives us x plus y equals 7 and negative x minus y equals -5. So when we add those together, we get 0 equals 2. But 0 is clearly not equal to 2. This sort of false statement is called a contradiction. If you find a contradiction when attempting to solve the system of equations, check your math. If you find a contradiction again, you can be pretty sure that there are no solutions to the system. We also previously noted that some systems of equations have many solutions. When we try to solve the system of equations 2x minus y equals 7 and 4x minus 2y equals 14, we must first multiply an equation by some number so we can eliminate a variable. And I will multiply the first equation by -2. That gives us -4x plus 2y equals -14. 4x minus 2y equals 14. And when we add these together, we get 0 equals 0. And we know that's true. This sort of true statement is called a tautology. That means it's obviously true. It's always a good idea to double check your math when you run into a tautology. If you get it again, you can be pretty sure that the system has multiple solutions.